Scientists define energy as the ability to do work. Modern civilization is possible because people have learned how to change energy from one form to another and then use it to do the work. People use energy to walk and bicycle, to move cars along the roads and boats through the water, to cook foods on the stoves, to make ice in the freezers, to light our homes and offices, to manufacture products, and to send astronauts into space. There are many different forms of energy, including heat, light, motion, electrical, chemical, and gravitational. These forms of energy can be grouped into two general types of energy for doing work: potential or stored energy, and kinetic or working energy. Potential energy is the energy that is stored in an object due to its position, relative to some zero position. The kinetic energy is the energy that is possessed due to its motion. It is defined as the work needed to accelerate a body of a given mass from rest to its stated velocity. Energy can be converted from one form to another. For example, the food a person eats contains chemical energy, and a person's body stores this energy until he or she uses it as a kinetic energy during work or play. The stored chemical energy in coal or natural gas and the kinetic energy of water flowing in the river can be converted into electrical energy, which in turn can be converted to light and heat. There are many different sources of energy which can be divided into two basic categories. First, renewable energy sources that can be easily replenished. And second are the non-renewable energy sources that cannot be easily replenished. Renewable and non-renewable energy sources can be used as a primary energy sources to produce useful energy such as heat, or they can be used to produce secondary energy sources such as electricity and hydrogen. Matter is everything around you. Atoms and compounds are all made of very small parts of matter. Those atoms go on to build the things you see and touch every day. Matter is defined as anything that has mass and takes up space. Even though matter can be found all over the universe, you will only find it in few forms or states on Earth. Each of those states is sometimes called a phase. There are many other states of matter that exist in extreme environment. Scientists will only probably discover more states of matter as we continue to explore the universe. So what are the main states of matter? Everyone should know about solids, liquids, gases, and plasmas. Scientists have always known about liquids, solids, and gases. The plasma was a new idea when it was identified by William Crookes in 1879. What makes a state of matter? The state of matter is all about the physical state and energy in the atoms and molecules. Think about solids. Physical properties of a solid often include hard and brittle. The liquids are fluidy, move around a little, and fill up a containers. Gases, on the other hand, always are around you, but the molecules of gas are much farther apart than the molecules of a liquid. If a gas has an odor, you will often be able to smell it before you can see it. The energy and the matter characterize both physical and biological systems. These systems are defined both by the types of energy and matter they contain and by how the matter and energy move through between the systems. In natural systems, both energy and matter are conserved within a system. This means that energy and matter can change forms but cannot be created or be destroyed. Energy and matter are often cycled within a system. and different forms of matter and energy are able to interact. The surrounding environment must be considered when studying a system's energy and matter to examine the flow into and out of the system. Scientists seek to study the flow and interaction of matter and energy, while engineers often seek to minimize inputs and maximize outputs of matter and energy relative to a given system. An environmental cycle is the process in which elements are continuously cycled into various forms between different compartments of the environment. These cycles includes the carbon, nitrogen, phosphorus, and the water cycle. The carbon cycle includes the uptake of carbon dioxide by plants through its ingestion by animals and its release to the atmosphere through respiration and decay of organic materials. Human activities like burning of fossil fuels contribute to the release of carbon dioxide in the atmosphere. The nitrogen cycle involves the uptake of nitrogen from the atmosphere by the process called fixation, which is carried out by microbes and industrial processes. Decomposition of biological waste by microbes can return nitrogen to the atmosphere. Nitrogen is mainly used by humans as a fertilizer in farmlands, but its excessive usage can lead to the serious problems such as eutrophication. The phosphorus cycles involve the uptake of phosphorus by organisms. Phosphorus in the environment is mainly found in rocks, and natural weathering processes can make it available to biological systems. After the decomposition of biological waste, it can accumulate in large amounts in soils and sediments. Phosphorus is used by humans as a fertilizer in farmlands and in detergents. The overuse of phosphorus can lead also to eutrophication. The water cycle is the process by which water travels in a sequence from the air to the earth and returns to the atmosphere. It is also referred to as the hydrologic cycle. Human use of water can transform the water cycle through irrigation or the construction of dams, for example. This cycle on Earth connects the energy and molecules on the planet into continuous loops that support life. The basic building blocks of life, like water, oxygen, carbon, sulfur, nitrogen, and phosphorus, are recycled go back into their respective cycles repeatedly. The cycles also create reservoirs of these building blocks, such as water stored in lakes and oceans, and sulfur stored in rocks and minerals. Any of the natural pathways by which essential elements of living matter are circulated. The cycles move through mainly the biotic and abiotic components of Earth. More elaborately, the spheres, biosphere, lithosphere, hydrosphere, and atmosphere regions of the ecosystem. These cycles, it involves the biological, geological, and chemical components that make out to complete an exact and purposed cycle.